Our next notes are on more solving and condensing logs. So we're using that to solve. And here we have log base 6 of x plus 4 minus log base 6 of x minus 5. We can condense that to get log base 6 of x plus 4 divided by x minus 5, because the quotient of two logs can be created from the subtraction of two logs. So now that we have it in one log, we can go ahead and turn it in exponential form. So 6 to the first power equals x plus 4 over x minus 5. We multiply by x minus 5 on both sides. We have 6x minus 30 equals x plus 4. And so we have 5x equals 34, and x equals 34 fifths. Then on the next problem, we have another situation with three logs. We're going to condense the logs on the left-hand side to get log base 5 of the quantity x plus 5 times the quantity x minus 3. Well, that equals the log base 5 of 3x minus 3. Well, the only way for two logs of the same base to be equal is if their arguments themselves are equal. So this argument, x plus 5 times x minus 3, has to be equal to this argument, the 3x minus 3. Well, this is a quadratic. We can solve this. You have x squared plus 2x minus 15 equals 3x minus 3. We get one side equal to 0. We get x squared minus x minus 12 equals 0. So this is x minus 4, x plus 3. So x equals 4 or negative 3. But hold on. If we look here at each of these arguments, the arguments must be positive in a logarithm. If 4 goes into each of these, you have 9 as the argument, you have 1 as this argument, and you have 12 minus 3 there, which is also 9. And if you input the negative 3, though, you get negative 6. And here you also get negative 12. That's not okay. Our only answer is x equals 4. With these two additional problems, we're going to do much of the same. We're going to condense these into one log. So log base 7 of x squared plus x equals log base 7 of 15 minus x squared. So we have x squared plus x equals 15 minus x squared. And so 2x squared plus x minus 15 equals 0. So we can go ahead and factor here. We have 2x and x. And let's see, we'll go minus 5 and plus 3 equals 0. I'm going to double check my middle terms really quickly. This here is 6x minus 5x is x. So I'm more confident in our answers of x equals 5 halves and x equals negative 3. Well, 5 halves I know is positive. So log base 7 of 5 halves, that's a thing. We can do that. Log base 7 of 7 halves, that's also a thing. We can do that. I'm a little concerned about this minus x squared, because if you did 15 minus 25 fourths, because that's 5 halves squared, well, 15 is 64th. So I know that this is also positive. So all three of those positive, that's okay. Now the x equals negative 3. Negative 3 plus 1 is negative 2. That's an issue. We cannot have negative 3 as a solution. Then, in this last problem, much of the same, we're going to go ahead and do log base 4 of this, this quotient. We have x plus 7 in the numerator because it's the positive one, and x plus 3 in the denominator because it's the negative is what we're subtracting. That equals 2. So 4 to the second equals x plus 7 over x plus 3. And now, as consistent with all of these, it becomes a problem that we've solved this type of thing before. So we had 16 over x plus, equals x plus 7 over x plus 3. We can multiply by x plus 3 onto both sides. So we get 16x plus 48 equals x plus 7. So we have 15x equals negative 41. So x equals negative 41/15. Well, x can be a negative number. It just has to make sure that it keeps our arguments and our powers, our arguments and our bases both positive. The base of 4 is already positive, but negative 41/15 is a little bit under negative 45/15, so it's a little bit smaller than 3. So that will keep this positive, and this will be positive as well. This is our answer.